And we can actually look so far out that we can see almost back to 13.8 billion years ago, which is very close to the Big Bang. We now know how our world ends. Our affinity with sci-fi movies and perhaps the Bible would point toward the big bad apocalypse. But what if we tell you that the end of the universe is no different than its inception? The James Webb Telescope has revealed that the universe has stopped expanding. Popular scientist Brian Cox made this prediction years ago. In doing so, he gave us the most realistic starting point to imagine the end of the world. We can look to light that began its journey before there were galaxies, and that's the oldest light in the universe, which is, by the way, one of the pieces of evidence for people who don't believe in the Big Bang. The answer is, well, you can see it, we're heading towards Big Bang 2.0. Join us as we explore why the world has stopped expanding and James Webb's terrifying discovery. If we're certain about anything in our knowledge of the universe and its history, it's the fact that our very epic existence is centralized around this event called the Big Bang. Of course, there are alternative theories that recognize the beginning of the universe, such as eternal inflation or an oscillating universe, but we're not getting into the validity of these theories today. Mainly because the astronomical community has now readily accepted that our history in this universe starts with a Big Bang, and the ideas that succeed the Big Bang are also based on the same common point of a universe's birth. While the Big Bang is a common word in the theoretical knowledge of astronomy and space, we're hardly aware of the nuances and the hows of the phenomenon, unless you're a nerd who has spent hours watching some excellent visualization of the Big Bang. To be fair, the phenomenon was more than an explosion, or so to speak. Simply put, the Big Bang finds its origin in a single point, a point that was infinitely hot and dense that inflated to extreme lengths. All of this was when the universe was incredibly young. Believe it or not, at the time of the Big Bang, the universe was only 10 to the power of minus 34 seconds old. That is 1/100th of a billionth of a trillionth of a second in age. This is when the universe experienced an incredible burst of expansion, aka the infamous explosion or the inflation. During this process, the space expanded faster than the speed of light. So yeah, you wouldn't have even blinked when the universe grew 90 times in size almost instantaneously. From subatomic size to golf ball size, 1 second after the inflation, the universe began to cool, and that led to the formation of matter as we know it today. So yeah, as far as the timeline goes, within a second our universe was full of every particle we've learned about in our chemistry class, willingly or otherwise. Protons, neutrons, electrons, anti-electrons, photons, and neutrinos are the legacy of the Big Bang. Magical, right? Well, figuratively it looks like it, but our understanding of the universe's inception is highly theoretical. We've come a long, long way since the first moon landing, and since then, our technological advancement has grown exponentially. Back when scientists were studying the Big Bang only based on mathematical formulas and scientific models, they wouldn't have imagined that we'd be exploring the possibility of life on Mars. There have been some big breakthroughs in our pursuits to study the universe and explore space, yet even then, our existing technology is pretty limited. You see, we can't recreate the Big Bang or peer back at the event itself. Our biggest piece of evidence comes from the cosmic microwave background that has allowed scientists to observe the echo of the Big Bang. While this mechanism is groundbreaking in the study of the universe, it's also theoretically limited. The biggest barrier in this particular methodology is the fact that we can't see the gravitational waves or the residual radiation that came from expansion itself. So while our entire knowledge rests on theoretical tenets, scientific theories have a large room to be disproved as well. Yep, we're pretty sure about the Big Bang as a concept and how it was monumental in creating our universe, but there are some chunks of its aftermath that we've gotten wrong. And as shocking as it is, theories about our universe are largely based on data that is prone to human errors all the time. At the same time, some of our data is also highly conclusive about the Big Bang. Let's just say that at this point in time, it's not easy to disprove the theory altogether. In the last decade or so, our only saving grace to study the Big Bang was the Hubble Space Telescope, and now, of course, all bets are on the excellent precision of the James Webb Space Telescope. Before we got to use these powerful technological instruments, one of the biggest points of contention in astronomical study was the expansion of the universe. If you pick some science textbooks from the early 90s or so, you'd read about how the universe is widening. In other words, the universe is expanding, and that's one little scientific fact that we've held on to. But the real snafu here is that perhaps we don't understand what the expansion of the universe entails. More importantly, we've got to ask ourselves if the universe is actually expanding because, spoiler alert, the James Webb Space Telescope is telling us otherwise. Lo and behold, the universe has stopped expanding. And hey, while the world is still intact, you might want to improve your internet experience, safe and secure, because we certainly have. This is why we're happy to reveal our very own secret to secure browsing and accessing deep content to make some hefty informative videos. So while we thank Atlas VPN for sponsoring this video, click the link in the description to avail the limited time offer. Your internet experience just got a whole lot better. Now, before jumping into the implications of this groundbreaking shift from our universe's trajectory, let's just talk about our understanding of this perplexing phenomenon in the first place. The most common knowledge associated with the Big Bang characterizes it as an explosion. And well, fiction and popular media have put solid imagery to this process as well. Any piece of media would depict the inception of the universe as some sort of a blast that honed tons of energy and matter just spread in every direction. Scientifically speaking, that sort of visualization isn't correct. Despite the widespread use of the explosion and inflation of the word, the birth of the universe wasn't exactly a blast. Scientists want us to correct our understanding of the universe. In NASA's own words, the universe did not expand into space, as space did not exist before the universe. Instead, it is better to think of the Big Bang as the simultaneous appearance of space everywhere in the universe. Our understanding of the phenomenon also reveals that our universe has lived through a durable cosmic period that was only disrupted by the reionization in space. Before that particular chemical conjecture, our universe was just pitch black dark. The let there be light moment of the universe only occurred 400 million years after the Big Bang. Yep, that's right. You see, the big explosion only created the basic tenet of all living beings and heavy bodies in the universe. For 400 million years, the universe was plunged into darkness because, well, it's simple, there were no stars or galaxies. When that was rectified, as clumps of gas turned into stars and galaxies, only then did the universe get out of its cosmic dark ages. So here's a little trivia for you guys. When do you think our solar system came into being? If the universe was just darkness and eeriness for 400 million years, well, our solar system was born 9 billion years after the Big Bang. So yeah, sorry sci-fi movies, there's a huge disconnect between the so-called explosion and scientific theory, and of course, this changes everything. The way things are, our universe still exists as a single inception point. It hasn't moved or expanded ever since the Big Bang. What really happens is that space has been stretching a long time, and it carries matter with its trajectory. To put it in clear-cut words, the universe isn't expanding the way we visualize it or even understand it. It is actually the active stretching of space that precedes the expansion of the universe. We know it's a bit complicated to comprehend this, but it's also important to understand the implications of what we're about to tell you. For the purpose of this video, we continue to use the phrase the expansion of the universe to signify the active movement of our space, mainly because even scientists are comfortable using the exact framing to describe the recent discovery made by the James Webb Space Telescope. The fact that the universe has stopped expanding is both terrifying and inconsistent with our previous theoretical knowledge of this baffling phenomenon. So what do we make of it? Let's get right into that. To understand the scope of the implications, we need to go back to our existing studies of the universe. Back when the universe was born, aka during the Big Bang, our universe was smaller than a single atom. Ever since then, the universe has been stretching outward continuously. Initially, it expanded outward at unfathomable speeds, but as the universe grew older, it continued to expand and stretch out more. This is the moment that everyone thought would last forever. After all, if the Big Bang was a beginning of sorts, we should expect a corresponding end. Our theoretical knowledge hence suggests that our universe is set on a singular trajectory of expansion without any plausible probability of a slowdown. In other words, we were sure of the ever-expanding nature of the universe, and that idea would have allowed us to figure out how and when the world would end. The James Webb Space Telescope shatters our preconceived notions of the universe's expansion. First things first, JWST's new study reveals that the universe has stopped expanding. The new images that the James Webb Telescope has received suggest that the universe's expansion has considerably slowed down. If anything, the universe may not be expanding at all. How exactly did this discovery come about? Well, with the recent images, scientists have revealed that the light waves have been seemingly bending as they have traveled through space and time. The very bending nature of the light indicates that it is the space that has stopped expanding. The new images reveal something that is far beyond what the Hubble Space Telescope has achieved. Our previous knowledge was based on Hubble studies and hence didn't reveal the most important aspect of the universe. The new images have shown that the universe is essentially curved. The mind-boggling discovery, therefore, shows that the universe is a sphere, and our very existence, including space and time, is wrapped inside the sphere. With this, another major breakthrough is the light that has reached the new telescope, and the more we look at the images, the more proof we have that the Big Bang theory is both true and outdated. It is true because the universe began at one point and it has been ever expanding, but at the same time, it is outdated because the expansion of the universe's stretching has been largely debunked with JWST's new data. If we study the data, we see that the universe, aka the spherical point, has stopped expanding, and that very characteristic of the universe hints at the most plausible fate of the universe's end. As we said, the universe was created with a Big Bang, but we have never stopped to wonder what would be the exact nature of the universe when it ends. Scientists have revealed the possibilities of how the world ends, and spoiler alert, it's going to end the same way it began. The expansion has stopped, and what happens next is that the stretching of space would also slow down. The new data also reveals the plausible end, which is the Big Crunch. We know it's too much for anyone to wrap their heads around, but JWST is allowing scientists to observe the mechanisms of the universe. By doing so, we are now aware of the universe's trajectory. Instead of accelerating the expansion, the universe has stopped expanding, and hence, with time, this curve or the sphere that holds our universe would gradually collapse. This theory isn't new to scientists, but it's only with the James Webb Space Telescope that we have the evidence to confirm it. Imagine it as a full circle. Our universe has reached its peak of expansion, and soon enough it would start collapsing on itself. This collapse is the end of the universe as we know it. The James Webb Space Telescope is an amazing creation that is paving the way for how we understand the universe. The latest images from the telescope reveal that light is bending at the edges, which means our universe has stopped expanding, and it also means that we're closer to our ultimate end than we thought. Whether this is going to happen in the next few centuries or a few thousand years is anyone's guess. But for now, our knowledge of the universe has reached an unfathomable stage, which, by the way, is pretty terrifying. So yeah, that's all for today. Let us know your thoughts on the video. Do you believe that the universe has stopped expanding? Does this discovery terrify you or make you excited? Don't forget to hit like and subscribe for more videos like this. To fully grasp the implications of the James Webb Space Telescope's revelations, we must delve deeper into the concept of the Big Crunch and its potential consequences for our universe. The idea of a Big Crunch is based on the premise that the universe's expansion will eventually reverse due to gravitational forces overcoming the momentum of the initial expansion. This reversal would lead the universe to collapse inward, essentially squeezing all matter and energy back into a singularity, a point of infinite density. This process contrasts sharply with the previously held belief that the universe would continue expanding indefinitely, eventually leading to a big freeze, where everything becomes so distant that stars burn out and galaxies drift apart. Another intriguing aspect to consider is the role of dark energy in this new context. Dark energy, which was once thought to be responsible for accelerating the expansion of the universe, might have a different role in a universe that has ceased to expand. If the universe's expansion has indeed halted, scientists will need to reevaluate the properties and impact of dark energy. This could lead to a deeper understanding of the fundamental forces at play in our cosmos and potentially reshape our entire model of cosmology. Furthermore, the implications of this discovery extend beyond theoretical physics. If our universe is indeed headed towards a big crunch, it may affect our approach to studying cosmic phenomena and planning future space missions. For instance, understanding the end state of the universe could provide valuable insights into the ultimate fate of celestial bodies and the behavior of cosmic structures under extreme conditions. This knowledge could influence how we prioritize astronomical research and allocate resources for space exploration. On a more speculative note, the concept of the Big Crunch raises questions about the possibility of a cyclic universe. Some theories suggest that a Big Crunch could potentially lead to another Big Bang, initiating a new cycle of cosmic evolution. This cyclical model proposes that our universe might be part of an ongoing series of expansions and contractions, each leading to a new phase of creation. If true, this could imply that the end of our universe is not an absolute end but rather a transition to a new cosmic cycle. The James Webb Space Telescope's data also opens the door to re-examining the nature of spacetime itself. The notion that the universe's expansion has halted suggests that spacetime could be behaving in ways we hadn't previously anticipated. This could lead to new theories about the fundamental nature of reality and the potential for breakthroughs in our understanding of gravity, quantum mechanics, and the fundamental structure of the universe. In conclusion, the James Webb Space Telescope's findings challenge our previous notions about the universe's expansion and its ultimate fate. As scientists continue to analyze the data and refine their models, we may uncover profound insights into the nature of our cosmos. This ongoing research underscores the importance of staying curious and open-minded in our quest to understand the universe and our place within it.